Okay, class, in this video we will be talking about a process called dimensional analysis. Now, this process is basically a tool that we use for converting units, and we know that a unit is the thing that we put after a number that tells us what that number is measuring. So if it's meters, we know that we're measuring length, or if it's milliliters, we know that we're measuring a volume, or if it's seconds, we know that we're measuring time. But sometimes we want to convert these units because depending on what type of unit we use, it could tell us if what we're measuring is really big or really small. For instance, if I have a really small volume of water, I might use milliliters. But if I've got a larger container full of water, like a 2 liter bottle of pop, I'm not going to use milliliters for that, and you'll notice that the label for that is going to be liters. So it's useful to be able to convert between these units because sometimes we have a measurement in one unit, but we want to go to a different unit. So we can use dimensional analysis to do this process. Now, a lot of you guys are thinking, I could probably do this in my head. This first example here says you've got a 12-to-1 ratio when you're talking about inches to feet. And if I said how many inches are in 2 feet of something, you could probably really easily in your head say there's 24 inches there because there's 2 feet. Or for instance, this example here, if I said how many days were in a year, you could easily do that math in your head because you know those conversions. But it is really, really important to learn how to use the process of dimensional analysis because down the road, here in the next video or so, when we start talking about units that you guys do not know, such as the mole, you will want to have this process mastered so that you're not trying to learn both the process and a concept at the same time. So some of this will seem really easy, and it'll be the kind of problem where you'll say, well, I could just move the decimal place. But I would encourage you to learn this process and pay good attention and take good notes so that you can replicate this down the road. Now, there's 3 important steps to dimensional analysis. And the first thing is to start with what you know. Usually in a dimensional analysis problem, you're going to see 2 different sets of units, and you'll want to pick the unit that has a number associated with it, the one that we know the number for. The second step is to let your units be your guide, and I will kind of explain this a little bit more once we get down to the problem. And the third one is going to be round reasonably. Now, this rule will change in a couple units when we start talking about significant figures, but for right now, just round to a reasonable number. If you have a number that has a really, really, really long decimal, don't worry about writing all those numbers down. Just pick to round to like the 10th place or the 100th place, or at most the 1000th place. So for this first example here, we have 3,600 milliliters, and we are converting those 3,600 milliliters to liters. And one quick note here, I often will refer to dimensional analysis as fence and rail. And I'll show you what I mean here in a second, but I think it's an easier way to organize your data, and I think it makes everything a little bit more organized in your paper. So I'll show you kind of what I mean here. But the first thing we're going to do is start with what we know. And what we know is this number here, 3,600 milliliters. So we're going to start by writing that down. And one thing I will always emphasize is to write down your units. Because if you don't write down your units, you're not going to be able to let your units be your guide. So we're going to write that down. We've got 3,600, and I'm just going to write the abbreviation here, milliliters. And then I'm going to draw my fence and my rail. So this is what it looks like. There you go. There's my fence and my rail. And now I'm going to, I just did this step. I did start with what you know. And now I'm going to do this one here. Let your units be your guide. So I've got milliliters on top, but I don't want my final answer to have milliliters. I want my final answer to have liters. So what I'm going to do is when I convert, I'm going to put my unit that's on top here also on the bottom so that it cancels. So what I'm going to do before I even start putting numbers in here is I'm going to put the same unit I have on top down here on the bottom. Now if I look at my problem here, I'm converting from milliliters to liters. So I want to put liters up here on top because that's what I'm trying to finish my problem with. So I've got 3,600 milliliters. I've got liters and milliliters. And then the next question I want to ask myself is which unit is the bigger unit, liters or milliliters? Well, if you know anything about volume, you know that liters, 1 liter is much bigger than 1 milliliter. And so I'm going to give my biggest unit a 1. Okay, so liters got the 1 there. And then we have to ask ourselves another question. How many milliliters is in 1 liter? And we know that answer to be 1,000. So we've got 1,000 milliliters in 1 liter. Now we're just going to multiply across and divide now. So 3,600 times 1 divided by 1,000 gives us 3.6 liters. Now you might say, Mr. Lundy, that's pretty easy. All I would have had to do is move the decimal there. And I'll say, yep, you're right. That's true. But often the way I grade is if you have the right answer and the right work, you get full points. But if you have the wrong answer and the right work, you'll get at least partial credit. So I would encourage you to show your work. Also on this next example here, you will see that we have multiple steps. So it gets harder to just move the decimal place. So for our next one, we're going to start with what we know. We've got 155,000 centimeters, and we want to convert that to kilometers. Now this one gets a little bit more complicated because it's probably not a good idea to convert straight from centimeters to kilometers because we know our base unit for length is the meter, and a centimeter is smaller than a meter, and a kilometer is much bigger than a meter. And that meter is that base unit. So we always want to convert to the base unit first, and then we can go up or down to the next unit. So we're going to convert first from centimeters to meters. And the first thing we want to do is we want to write that unit down on the bottom so that we know that centimeters will cancel. We know we're going to convert to meters. Okay, that's the letting your units be your guide. And then we ask ourselves, which is bigger, meters or centimeters? And we know that meters are bigger, so meters get the 1. And then we know that there are 100 centimeters in 1 meter. Now our question asked us to convert to kilometers. So we're not done here yet. We have to draw another fence and rail and continue on with our problem. Now we want to do the same thing here. We've got meters up top, so we also want to put meters on bottom here. But now we can go to the unit we're converting to, which is kilometers. And now we're going to ask ourselves the question again. Which one is bigger, kilometers or meters? Kilometers is bigger in this case, so our kilometers gets the 1. And we know that there are 1,000 meters in 1 kilometer. Now this step here, you can do one of 2 ways. The first thing that you could do is take 155,000 and divide it by 100 and then divide it by 1,000, which is usually what I do. Or you could multiply 100 and 1,000 together and then divide 155,000 divided by that number. For the sake of this video, I'm just going to do the calculating on my own. I don't really care which way you guys do it, as long as you make sure you're going through all the steps. And you get an answer of 1.55 kilometers. Now this last one I picked because this is going to be similar to what you encounter once you start moving on to chemistry conversions. You're going to have units like the mole that you're not going to be very familiar with. And so I picked a conversion that has a unit that you won't be familiar with, so you can't just do some decimal moving in your head. You've probably never heard of the unit, the furlong, but the furlong is a unit of measurement, and in 1 furlong, I don't even know the abbreviation. In 1 furlong, There are 660 feet. So now we have to do some conversions here. We're converting from furlongs per minute to miles per hour. And this is going to get complicated because now we don't just have a unit in the top, we're also going to have a unit in the bottom. So we're going to first start with what we know. We know we have 35 furlongs, and I'm just going to abbreviate that to be FL. We have 35 furlongs per minute. So I'm going to draw my fence and rail, and furlongs are on top and minutes are on bottom. So we've got furlongs per minute, and we are converting to miles per hour. Now it's important to know we can only convert one unit at a time. So let's start with the minutes because we're familiar with minutes. So we want to convert from minutes to hours. So we're going to put minutes on top because we want to cancel minutes, and we're going to put hours on bottom. We ask ourselves which one is bigger. 1 hour is bigger. There are 60 minutes in 1 hour. And so we've taken care of this part. We've converted from minutes to hours. Now, we also have to convert our unit of length from furlongs to miles. So that's going to be our next step. We've got furlongs on top over here. And so we are going to draw another fence and rail, and we're going to put furlongs on bottom. And furlong has a conversion where we probably need to go to feet first before we can go to miles. So we're going to go from furlongs to feet, and we have our conversion here that tells us that 1 furlong is 660 feet. So we know that, oh, I didn't draw my cross there on my T. Oh, that's an ugly cross. There we go. So in 1 furlong, we have 660 feet. And we gave furlong the 1 because it's a bigger unit. Now we need to convert from feet to miles. So we're going to put feet on bottom because we want to cancel feet with feet, and miles on top. Miles is much bigger, so it's going to get the 1 here. And we have 5,280 feet in 1 mile. So we look at our units here. Our minutes cancel with minutes. Our furlongs cancel with furlongs. Our feet cancels with feet. And if you look at the stuff that we don't have crossed out, we have miles on top and hours on bottom. If we multiply that through and put it into our calculator, we multiply across and divide what we have on the bottom, we should get 262.5 miles per hour. So that's how you do dimensional analysis. This will come in really, really handy down the road when we start talking about the mole and we start converting there. So just remember, always start with what you know. Secondly, let your units be your guide. Make sure that you can always cancel things off to finish with what we want. And lastly, make sure to round reasonably. Thank you, and see you in the next video.